Okay, good afternoon, everybody. Thank you for joining us in this new lab. So for now, we're going to be starting a new block in our learning labs. And this one is going to be more focused on machine learning and some applications in the oil and gas industry. So for today, I'm going to share my screen now. And for today, that's the lab you're going to be presenting. Natural language processing and machine learning. So let me just stop my video as well. So I'm not gonna be on the top as well. So that's the presentation for today. Natural language processing and machine learning to classify severe injuries in the oil and gas industry. So that's a project done by me and Daniel Tread. So for the agenda of today's presentation, today's session, we're going to talk a little bit about the Cruise Data Science Initiative, as we always do. I'm just going to put a laser pointer here. I'm going to talk about give a report demonstration. So for this session, we are not going to actually be doing an app. We're going to be doing another way to deliver your work to the client or to your whatever you have to. So in this case, it's going to be a PDF report and how you can create a PDF report straight from the R session. Then we're going to talk about the severe injuries, the data that you're working with, and a little bit of the natural language processing, how we're going to be converting non-structural data, that is texts, to a structural data that are like a spreadsheet that you have a bunch of numbers that you can process and do modeling. And I'm going to be using the random forest classifier. And I'm going to also talk about the R and Python, how to work with them together. We're going to be doing most of the processing, pre-processing in R, and some parts like the Tf Idf and the random forest, we're going to be doing in Python. And then I'm going to be converting the data between one and another. So the hosts for today, it's me. I'm Marcelo Guarido. I'm a data science, and I have a PhD in geophysics, and I'm the head of the Cruise Data Science Initiative. And Daniel, you can present yourself.
Yeah, and I am associate professor in the Department of Geoscience, and also helping Marcelo with this initiative and bringing a bit more data science, machine learning to Cruise. Thank you.
Thank you, Daniel. So the Cruise Data Science Initiative, as Daniel talked, we've been working together in a lot of machine learning, artificial intelligence, and all related to data science, focused in the geoscience world and also in the oil gas industry, engineering, and other type of data. And they're doing projects that are both academic and also industry applicable. Other thing that we do is like those are trainings in programming, most specifically R, Python, and MATLAB. Those could be even from introduction to those languages to more applications, like in the geoscience, and how to apply machine learning and how to do something more specific. And also how to create apps using both languages. And another thing that we offer in the Data Science Initiative are those learning labs, the one that you're watching now. And you can access all the older files if you just click in this link in here. It should click. Probably because I'm in the pointer option. So let me just go out. So if you may click in this link, you're going to open all the data science tab in the Cruise webpage. And we have all the old labs in here. We can watch the videos and download the files as well, in which we worked on those previous labs. So the first thing that I like to show you is the report demonstration, what you're going to be creating today. So I'm just going to open the PDF with the report. And that's what we are going to be creating today. We're going to be doing this analysis in the natural language processing, and they're going to be creating this beautiful report that you can deliver straight to your client And all those outputs you have in here, they are created in R and Python. So this come from an R Markdown. So basically, when I run this R Markdown in here, it's going to be exported to a PDF document. And you can also even change the type of template that you want to run in the background. For this demonstration, I'm using the regular template, the standard template they have in here. So that's how it, and you can include all the latex information. It's going to be latex based, this kind of a report, and you can include all things that you want. You can include the hyperlinks and everything in here. So it's quite of nice. So now let's go into back to the presentation. So let's first talk about severe injuries. What you're talking in here today, the data that you're using, it's about severe injuries in the industry in the United States. So that's everything that is an injury that has some high level of severity, like concussion in the head, when you have fractures, amputations, like lost a finger, but we don't have death here. Even though we have in this example, this image, we don't have anyone dying in those reports. So what it is done, the companies, they have to create a report of the incident, the accident that occurred, and then send to the Occupational Safety and Health Administration in the United States. That's called OSHA. So, and that's from where we are downloading the data. So if you go here back, we have the Occupational Safety and Health Administration, the OSHA, and here you can download for the severe injury reports the data that they have since 2015 until the latest day possible. And this one is the March 31st of this year. You're going to be using our older data set, but that's okay. It's just for demonstration. So what are those reports actually? Those are reports that they send. They have different types of injuries that they have classified in here. And each one is part of a different class. So we have the type of injury that could be fractures, amputations, burn. We have a bunch of different ones. We have a lot of other information about location, part of body, and here I'm just putting a few one. And we have the description. So what you're going to be doing in this project is by reading this description, how can we get the type of injury, if it's a fracture or if it's an amputation. And why this is important? Because depends of the company, they might classify different type of injuries or the same type of injury with different classes. For example, fracture, someone can say broken arm or broken leg. So those are the same thing, a fractured leg, but they are in the data analysis considered different classes when you're going to do the analysis. So what you're going to try to do is to create a model that are going to standardize all the classification of the injuries. But our question is, we have this non-structural data. Those are texts. It's just a document. So how we can convert this to a spreadsheet? So that's our question today. And for that, we're going to be using a methodology called Tf Idf. So those are a few equations. So Tf Idf stands for term frequency and inverse document frequency. And what you're going to be doing, we are going to taking all those descriptions and just separate each one of those words as a title of a column or the name of a column. So each one of these is going to become a column. And you're going to count every time a word appeared in this description or in this report, and they're going to give a weight to this word. So that's how we calculated the weight of this word is that with the Tf Idf. The TF means the common locally, or how many times a specific word appeared in a specific document. For example, if you see here the word correction, let me just go back one. Correctional, it appeared just one time in this part. So this one would be one, or the word, let's say, he appeared twice, here and here. So the TF would be 2 for this word. And then we have to multiply by the IDF part. So the IDF is the frequency that the word appears in different documents, or it's this global rarity. So it's this equation, the log of the number of times the word appeared in all the documents, not how many times in different documents, not like, so it's going to be 1 per document that appeared. And this NT is the total number of documents. So the weight is going to be the multiplication of these 2 parts. So it's going to be, for example, for the word he, is going to be 1. And for the IDF, we could expect that he is a very common word. So the IDF here is going to be very close of the log to 1, so it's going to be very close to 0. So the weight is going to be very low. So this is a way to account to very common words. So like word the, a, or things like that, it's going to appear basically in all the documents. So they are not important for classification. You want to use different ones like fibula, in this case, fracturing might be important to classify fractures, and so on. So for this, you're going to create a table. So it's going to be a spreadsheet. Each one is going to be a word, and you're going to have a weight for this word for each one of those rows. So that's what's going to be created with Tf Idf. And then you're going to have a structural data that you can do the classification. So for the classification, you're going to be talking about random forest. So we have a random forest. It's an ensemble of different decision trees. And what is a decision tree? A decision tree is when we have our features and we want to divide our classification depends of some threshold related to each one of the features. For example, in this one, if you have, if you are selling houses, and if you want to know if the person is a good buyer or not, you could say, okay, you could see all the information about the person. If he has a good credit history, if he has, it goes this side. If he not, goes this side. And in this one could be, it has a high salary, yes or no. And here we have other options. And depends of each one, you're going to be classifying, you're going to give a classification. Depends on each one of the way that that individual is going to run for this tree. And we have different, but decision tree classifier by itself, it's a very weak classifier. It's considered a very weak classifier. So what we usually do, we do ensemble classifiers. We combine those three in different ways, like the gradient boosting trees and the random forest. For the gradient boosting trees is we create one tree after the other. So the first tree is going to be a simple decision tree that's going to try to classify, and it's going to calculate its residuals, how many the errors that calculated, and then it's going to try to fit a new tree over the errors. So we're going to be doing that until we minimize the errors the most possible. So it's one after the other. And the random forest, it's when you create a bunch of different trees and you try to classify all at the same time. So it could be run in parallel. Each tree is independent of the other. And in the end, we do a vote system for each one of the classes, which one was voted more. And that's how it's done, the classification. So let me talk a little bit about the R and Python together. So what you're going to be using in this package, Reticulate in R, where we can run inside our markdown chunks that can be R and other chunks that can be Python. And you can transfer the data between each other. For example, in this example in here, we are getting a data frame from R and convert it to Python. So we use this R dot and then the name of the data frame that exists here in R. So now it's a data frame in Python. So that's how you're going to be working today. You're going to be doing most of the analysis in R and the modeling in Python. So let's code. So for now, we can go to our session. So this is the code that you're going to be providing to you by the end of the session that you can download in the website. And if you go here, we have a bunch of different files that were created. So the most important ones are these markdown, the severe injuries, that's the project in R, and the utils.r. Those are just a helper functions that I included here to do some plots, like how to plot a confusion matrix and how to create a confusion matrix. So that's the only thing that we have in here. And the bib.pb, that is the bibliography that you're going to be including in our PDF. All the other ones, they are created when you run the init here in the markdown. So if you actually delete everything in here and keep only the ones that I said that are important, even the severe injury files, those severe injury files is when you're creating images, is going to get your images that you're creating in here, and it's going to save in a LaTeX format. So it's going to take each one of your figures and save in here. For example, this map. So it saves in here for after include in the LaTeX. So I'm also going to delete this folder. Oops. So let me again select everything that I want to delete and show that after we run, everything is going to be created. Yeah. So there are a few things. Okay. So I might have something running in the background here. No, that's okay. So that's how we do a PDF file. When you're going to be creating a new R markdown, for example, you can create which type of output that you want to have. And you can have to be a HTML, PDF, or Word. Or you can even have presentations, you can have Shiny, and you can have some templates if you install different packages. So for this one, for the documents, we are selecting a PDF. So when you create an empty one, as I'm going to give the example in here, it's going to create just this output file PDF document in your header. In here, we are just including some more configurations. So we have the output, and we have the PDF document, and then we are just setting a few things to be the same for the whole file. First is the figure captions. It's going to be yes, so we're going to be including captions of the figures. The figure size, we are mainly keeping here the same all the time, unless we change in the chunk. Here I'm saying to keep the text file, so it's going to create a LaTeX file, and it's going to keep in here. It's going to keep saved. This one and this one should be deleted. I think they didn't because it might be running somewhere. No. And the PDF, I cannot because it's opening here. Now I understand. So let me just close this PDF. And now I can delete here. And then I can show how everything is going to be created after I run. Okay, so I just need the markdown, the project, the bib, that's we are selecting the bibliography when we open in here. So that's just a bibliography file that you can use in LaTeX. That's how we include the articles and books and everything. And we create a tag for it that you can cite in the middle of in your text. So I'm gonna close this. I'm gonna close this untitled. I don't want this one. I was just showing an example. And I'm just changing some things like the highlights, December is just a little bit of the layout is changing. The data frame, when I'm going to be printing, I'm going to be using this cable package. So it's a little more beautiful to show than the regular one. And just include a few configurations in here. So what you're going to be doing, you're going to be loading a bunch of packages that we need for this part. And they're going to be using the tidyverse for the core data table, for plotting the tables and reading the file, lubridate to taking care of the time date. This TM, I believe, is for text manipulation. So you're going to be using this to do some text manipulations. This is for create the caption. The cable extra is also for the table that you're going to be including here. Some plots. So in this one, you're going to be creating static plots as you're going to be converting to PDF. And the Reticulate package. So for the Reticulate package, you need to have a Python installed. And you can also use the Conda environments or virtual environments. I like to install the Anaconda. You can create an environment. You can use different environments that you want for this project. In this case, as I'm commented, this part of code means that I'm going to be using the base. So for the Python installation, I really recommend to use the Anaconda. So it's very simple. It installs a lot of things together, and it's good for package managing. So you go here and do the individual edition for the free Python, and then you can download. So it's going to be open source. You can download for Linux, Mac, or Windows, and you have everything. After you download and install, you can have the Anaconda navigator. That's going to be like that. And then you can start the Jupyter notebooks or other things that you have installed, like the VS Code, and start coding in Python in here. And for environments, you can create different environments. So environments are very important to be created when I use very specific packages that can override some basic packages in Python. So sometimes you create a new one, and you can just come here, create, you can just give it a name. You can select the version of Python that you want to use. There are some also packages that doesn't work in the latest one. Sometimes you have to go back to 3.7 or 3.6, so on. Or sometimes if you like to go for the 2.7, you can. And after you create, you can install packages in here. So going back in here, and you're going to be calling it here using the Reticulate package. So we're going to be showing there. This is how we install the Reticulate in R. And here it's just explaining to you how to use the Python inside R. So the same thing that you're going to be doing in here. And I'm going to be showing better in the code. But this is the web page if you need more information, and some articles and even some examples. Okay, so let's start here. So I'm going to first doing the init. So you're going to see that all the files are going to be created here. So init, you can select, this is also a package named init that you're going to create all those different files. You can create HTML, PDF, and Word in this case. In this case, you're going to create the PDF. So when you init, so you're going to start to be running this R Markdown tab in here, and you can see how it's going. So it's going to take a few seconds to run. So while it's running, I'm going to start to explaining the code. When it's done, it's going to pop up a PDF file. So first, let's all load all those packages. And I'm using this init R, that's the package. And for the chunks, all those options that I can include in the top of a chunk, I can set something in the beginning, because I know that I don't want to have the coding to be shown in the PDF. So that means that equal is equal false. That means the output is going to be put in the PDF, but not the code chunk. This part is not going to be there. It's not going to show, just the figures and the tables. Another thing is that I don't want any warning and any message being printed for the chunks. I'm just saying that I want the figures centered. This is for the capture, the caption. So we're going to be starting with figure, oops, and something. So it's going to be figure 1 and column and something. And this one is a position in LaTeX. So this is a LaTeX kind of command, means that we are forcing the image to be in the position with some floating. So we are trying to force to be in the position in the text the best possible, but allowing some floating around. So because it's a little hard to keep managing the position of your images. And the DPI is just the resolution of your images. If you don't set this, it's going to be a DPI very high, and your PDF files, they're going to be huge. So never forget to set this DPI. I did for 512. It's still a very good resolution, and the file PDF that's created is not too heavy. Okay, so everything that's outside a chunk is going to be considered the markdown or the LaTeX. So for example, if you want to do an abstract in here, we can use this LaTeX part, like a begin abstract, and here we type the abstract, and we finish it. A few differences come when you start a new session. Usually, when you're doing in LaTeX, you have to do like a begin session or something like that. Here, we are using the markdown, and if we're going to create a new session, we're just using the H1 header. So if it's a H2 header, it's going to be a subsection, and so on. But mainly, almost everything that's inside here is going to be the same as LaTeX. Like, for example, creating a table. That's how you create a table in LaTeX. You can even create a, where is it? We have a caption, and we have, where is it? We have a connection to this table, that label in here, where we can do the reference in the text. So when you created a PDF, we are going to have a hyperlink of the number that appears here into this table. And so on. You can include a lot of information. Another difference that you're going to have in Markdown here, let me just find before going through the codes, it's when you're doing citations. I don't think I have one so close here, but that's okay. I'll show. Okay, so it's done. Now we have the PDF that was created in the init file. So we created this PDF with all the information that we have there. And just to show you, all those files were recreated in here. So that's why it took a little while to run, because he had to recreate all those files. But we have the text file. So if you open the text file, so this is the LaTeX, and that's how it's going to convert our Markdown to a LaTeX file. So we have all those packages that it's calling, so the abstract, and remember the section, it's going to create automatically in here, and even a label it creates. So it's going to be data-description. So you can even do a hyperlink if you do a ref and this label in here. And even the images, when you create images, create figures, so it creates like the map that's saved in this folder, NLP, severe injuries files, and it goes there and just include the way that it does in a regular LaTeX. So that's how it's converted. And by doing that, you can actually create your own layout. So let's go a little bit to the code. Later, I'm going to look for the citation. So first, let's run this chunk to load all those libraries. So I'm going to be using Python, everything in here. And the data set I downloaded from the OSHA website. So I save it in here, so I'm gonna be providing this one. It's a little different. This data set is from the January 1st of 2015 to February 28th of 2019. It's 1 year less than what they have there, but this is just for demonstration. And I'm gonna be doing some process. So when you run this part in here, you can be press just Control Enter to run this selection. And then I'm gonna have this data frame. So if I wanna visualize in here, just click, and it's all the information that you have in this data set. So we have an identification number of the incident, a UPA, the date of the event, the employer, we're gonna be using these, the address, this is important for where we are gonna be plotting, city, state, zip code, latitude, longitude. This is very important. The snake number represents the type of industry that we have there, and everything that's related to oil and gas starts with 21. So that's how we're going to be separating all the companies that are oil and gas to the others. And if you have information, if the person was hospitalized, if there was an amputation, and you can sort here. Mistakenly, I just sorted. And how many people were hospitalized as well. So here we have the final narrative. That's our description that we're going to be using to classify the type of the injury. So our target is going to be the nature title. So we're going to be using this to classify this one. And you can do with this data set, for example, we have the type of the part of the body, the event title, we have way more information that you can use and do other type of analysis as well. So this is the data. And here I'm just doing some mutations, like in the name of the columns, just to be a little simpler. So when I run this, for example, now my data frame here changed as well. And I have just a better way to address the name of each column as well. And I also changed the order. I put next to be the first. Also, what we did here, I just converted the event dates to be recognized as a date object in here. You're not going to be using for this one, but you can also do a time series analysis in this data set. In this part here, I figure out in the data set that some of those companies, employers, they are sometimes posted with different names, like the US Post Center, sometimes is US Postal, sometimes United States Postal. So the same company has different names. So what I'm doing, I'm searching all those ones that I found and saving with a singular name. So I did it for a bunch of them, even for the oil and gas industries like the Halliburton. Sometimes you have the comma Inc. and energy services and so on. In the end, I'm just saving everything as Halliburton. Okay, so when I run these, I'm just gonna be fixing. So I'm gonna run this chunk, this whole chunk. So I'm just doing some pre-processing of the text part. So it's looking each one of them, and I'm replacing one text by the other. Here now, in this part, you're going to be creating a map with all the locations. So I'm just dropping all the NAs, in the F for the column next. So everything that has no industry, I'm going to be dropping out just in case. In here, I'm going to be filtering whatever is oil and gas is going to be related to the 2001 until the last number of the 21. And all the others one is going to be the ones that are not oil and gas industry. So for that, I'm using this GG map. So it's a Google, and you have to register for a key. So I saved my key in here. you can go for the, for example, if you look for the ggmap registration, you don't go. You can register in the Google like this. Okay, but that's okay. You just create a key that you include in here so you can download the type of maps that you want to use. Here I'm just setting that I'm gonna plot in the United States, and I'm getting the type of base map that I want to use. So it's gonna be a darker color with the zoom 5. So it's gonna be very focused on the United States. Here I'm just creating a few functions for the coloring and for the map, the mapping color, and so on. So I'm changing the black to a little less black in here. I'm creating a few, create a class of the map so we can plot things better. And here is the ggmap. So we're going to include the points, one for the oil and gas and the other for not oil and gas. And when we run this chunk in here, we have the map of the locations of all of the incidents that are oil and gas industry and the ones that are not oil and gas industry. And another thing that's very interesting is that I created this variable named cap. That's going to be the caption of this figure in the latex. So I create a label that you can address and write in here whatever is related to this caption. And to include the caption, you have to go here in the options of your chunk and say the caption of the figure is going to be this cap variable that I created down here. This first part is just the name of this chunk, so I can navigate better. For example, if I want to go back to this chunk, I just click in map. If I want to go back to the top, I just gave this name, so it's load, data, and fix, and so on. So here you create a map of the location of the incidents. So the red dots are the oil and gas, and the orange are the others. So we see that for the oil and gas, they are more focused in Texas, what makes sense, in the United States. Now we're going to do some analysis to see what are the most dangerous seeds to work on. So what am I going to be doing here? I'm going to be doing this for all the industries. So combining with the oil and gas, I'm going to do combining with everything. So I'm going to be grouping by city, and I'm going to be summarizing the count that each city appeared. I'm going to be including a descending and the top 10. And I'm going to be saving these as a data frame. So if I just run this part in here, so that's what I'm creating. What's the city, the most dangerous cities to work in, and the count of incidents that appear in there. And the same for the oil and gas industry. You can do that. See? So we have Midland, we have way more reports, also in Texas, but this is more where you have the production plant as well. So I'm going to run this chunk, and I'm saving all these. And here now I'm going to be creating just a plot of a donut plot that I'm going to show the most dangerous cities. So the ggplot by itself, it doesn't have a donut plot. So you have to do this. You have to create a bunch of polygonals and put each other. So here I'm just calculating the centers and so on. And then I'm going to create one plot for all companies and the other one for all the oil and gas. And then I'm going to save with this grid arrange to be just one figure. So when you're running here, we're going to be running, creating all those centers of the polygonals and everything. So we're going to be creating this image. So we have the 10 most dangerous cities to work for all the companies. So the most one is Houston, followed by Chicago, and so on. And for the oil and gas, we have first Midland, second Pecos. You see that Houston is not, apparently, is not even, it's here. So by the color is this one. So it has way less incidents than the other ones. The difference that Houston usually have more the offices for the oil and gas industry. So they have like a processing, engineering, the offices. But the work that requires like machinery and things that can create more severe injuries, not simple injuries, severe injuries, usually they're related to the field work. So that's why it's different in here. Another thing that you can check is the 10 most dangerous companies to work. So I'm going to be doing the same thing here, but for the employer. So I'm just going to run in here. And also I'm going to be creating this donut plot for both of them. So we can visualize in here now the 10 most dangerous companies to work with. So in this one, for all the companies named for it was the US Postal Service, the second one was the Walmart, and the third the UPS. So just remember, those are absolute number for severe injuries. So larger the company, more employees they have, more severe injuries they're going to have. And also it's going to be related of type of service. Walmart, you have all those storage areas that you are carrying heavy stuff. You can have like a severe injuries in there. And USPS and UPS is the same. For the oil and gas industry, we have the Halliburton. That's actually the largest drilling company in the United States. So we have more incidents. The second one is going to be these basic energy services. Also, for all this work, usually in drilling. So those are related to things that has very heavy and moving parts. So also those are relatively large companies, and larger the company, more incidents you're going to have. So that's not relative to the size of the company, this plot. Okay. But that's okay. You can work on that. You can search in the internet the size of the company, and then you can divide the number of incidents by the number of employees. So you can have like a ratio, severe injuries by number of employees. And this plot is going to change a lot. So here I'm going to be studying what are the top 10 injuries for, again, all the industries and all the oil and gas industry. So I'm going to be the same way. I'm going to be summarizing everything. And then I'm going to just be creating a plot. So this one is going to be just a bar plot. So when you run here, this one is going to be for all the industries. What are the 10 most common type of injuries? So we have fractures as first one, amputations as second one. So if you think that there is a lot of amputations, but it could be like just the tip of your finger, or could be your hand, could be the tip of your toe. So those are all considered amputation, but some are more severe than the others. So that's another project that you could work on to understand what's the severity of each one of these injuries. Even though a fracture, when you fracture a finger, it's very different when you fracture your leg with exposed bone, for example. So we have also soreness, pain, we have cuts, we have traumatic injuries, we have intracranial in the head, crushing, and a lot of things. Heat means burn. So when you do for the oil and gas industry, the same thing. It's going to be a little different. You have more amputations than fractures. And I believe because the oil and gas for the drilling part, you have more moving parts. So that could be a little more hard to avoid amputation in this side. And also, we don't have damage in the head like we had in here, intracranial injuries. So it shows that you don't have injuries in the head. What could be is a difference on how the rules are followed there. I worked in the field for a long time in the oil and gas industry, and the helmet is something that always you have to be wearing. So they are very strict to these kind of regulations. So that could avoid to the top 10 not have severe injuries in the head. So now let's start to talk about the natural language processing. So this is a nice example that you can include equations like we include in LaTeX. You can even give a label to do a reference in here. And here it's how, for example, you're going to be citing an author. So if you go back here in our BIP, we have this Aizawa 2013. That is this uninformation theoretic perspective of Tf Idf measures. And what you do arroba and the tag or the label that you created in here. That's this one. I put between brackets. That means that it's going to be in parentheses in your text. So it's going to be equivalent to a cite P. And if you don't have these brackets, it's equivalent to a cite in LaTeX. So those are just a few differences that you're going to have. Then in here, I'm just going to be preparing the data for the Python side. So I'm just going to be R-binding, combining the orders and data size. So I'm going to be ordering by injury. So I'm going to be separated. And I'm going to be creating a new column. The target is going to be the factor or a number that's going to be related to the injury. So when I run this only, now if I just print this df all, I'm going to have a last column that's going to be converting the type of an injury to a number. Let's see if you can find it. So we have all those type of injuries. Those are texts. And if you go to the last column that you have here, so now it's going to be a number related to that. So that's our first conversion from different classes we are just assigned. And here, this cable function is just a way to plot the table in PDF. So if you run here, it's not going to happen anything because this is going to be more specifically to the PDF. So it's going to be empty here, but when you run the init, it's going to show the table there in PDF. And you can also say, what do you want? I want to be a LaTeX. I want to have the book tabs. I want to be a long table. That means if the table is too long, it's going to divide it in the text there. And so on. You can include a label, the caption, and so on. So now you're going to be converting to Python. So you can create a chunk in Python. So it's the same way you create a chunk in R. So to create a chunk in R, you can go just to come here and you press Ctrl-Alt-I. You have a chunk in Python. You can just come here in R, sorry, and change it to Python. And then you can do your Python programming in here. And if you have the R Studio with the daily updates, you can actually also look for your global environments for the Python ones that were created. So when you run here, we have those in Python. So as we didn't run anything, we basically have nothing. So when you run this chunk as well, so what I'm doing here, I'm just importing some libraries and I'm converting the data frame, the one that I showed here, that are in R, to Python. So now I have this data here. So this is a data frame in Python. So if you just click in here, is going to be the same as we had there. So it's an object because it came from Python, but that's how we just converted them to Python. Okay, so now the next part in here, I'm just removing some punctuations. For the narratives, I remove all the comma, the dots, the everything that you have there. So we're just gonna define these functions, remove punctuation, and this is from the basis of Python. So when I run this as well, I'm just gonna be removing for the final narrative here in Python to not have all those information that I don't want to. Now this next part in here, I'm gonna be doing the words counting and Tf Idf. So the first thing that I want to do is to remove the stop words. So stop words, they are words that are not actually, oops, not running, so don't run. Because I have to run the chunk, it's different. So it's not running. Okay, so what are something like that happen? You have to just restart your R just to be sure that things are okay. And then you can click, for example, one of these down arrows. So it means that you're gonna run all the chunks above. So you're gonna be back to this point in here. So let's waiting for the session to restart. So it's resuming. When it restarted, you're just gonna be running here. It's because I clicked in a different way to run. I did the Control Enter, and then I create some internal wrong loop in here. So when I'm running the Python, I have to run the chunk. So I'm just gonna run everything above this chunk. So it's gonna appear here, everything that's running. It's gonna be quite fast. So it's gonna be here really soon. So okay, so let's go back to the word clouds for now. The stop words are words that are way too common, that are not important for our analysis, like the words the, a, he, she, that might not be too important if they appear in all the documents. So what I'm going to be doing, I'm going to be removing those stop words from all our final narratives. The final narrative, it's our description of the incident. The only thing of the stop words that I want to keep is the word not, because you can have a not fracture, not amputation. So I'm going to be removing this not. And here, from the scikit-learn, I'm using this feature extraction text. I'm going to be doing the Tf Idf transformer and the Tf Idf vectorization. So actually, I'm just using the vectorizer apparently, and also I'm not using the count vectorizer because the Tf Idf can do everything. So the Tf Idf, we're going to do the word count and so on. So when you're going to be running in here, the Tf Idf, you're going to be creating a model for vectorizer. It's like a machine learning model. We're going to have our stop words. Which one are our stop words? So the mean for Tf Idf and the max for the Tf Idf. That means that words that are way too common are going to be removed from our, besides the stop words, another words that are way too common are going to be removed from our data set, and words that are way too rare, we're going to also be removing, because sometimes you can have typos, and typos could be a problem. So a word rarity could be related to a typo. And this token pattern, so this is another way, another code. That means that you're not going to be using numbers, just that. So that's something you can search in the internet, how to do the token pattern. And then you're going to just fit our Tf Idf to our final narrative. And then you're going to apply the Tf Idf, and then you're going to create a new data frame that contains, sorry, all the Tf Idf. So let me just run this chunk, and then I'm going to be including in the end the target, the injury, and the next number, just to have everything. So we're going to be creating a new a new data frame that each column is going to be the word. So it's running here. So let's go check it in Python. And let's see what is this data frame that created. It's data frame Tf Idf. When you click in here, it's just going to take a while to open. And that's it. You see that each column is each one of the words that appear in each one of the reports, and it's giving a weight in here, the TF-IDF weight. So when it's 0, that could be a word that appeared in all the documents, or a word that didn't appear in this document at all. So each row is a report of an accident, so that's the weight of this word for this report, and so on. And I'm going to have this for all the words that we have in here. So actually, if we are just showing 27 columns, but in the total we have 270 columns. Means that you have 267 different words being accounted here. I subtracted these 3 because we included the target and injury and the next in here. In here, I'm just removing the last frequent classes because we're going to have a problem of that we have one class that appeared too many times and other classes that appear too less time. So we have a case of imbalanced classes. So when I run this chunk in here, I'm just going to end up with 32 classes in our data frame. So that's what I'm doing. So I'm just creating this df new that are going to have a little less classes than we had in the beginning, because we had 168 classes. Means that you have some type of injuries that can appear 1 or just twice or so on. So you want to use our classifier to work better in the one that the machine learning can learn something. And that's our new column. So it came now for 36,000 rows. And before that, we had, let's see how many rows we had before, 41,000. So basically we removed about 2,000 rows. Those are the less frequent classes. So here I'm just plotting which one are then. So they're going to be showing in the PDF. So I'm not going to run in here. Now I'm going to be splitting in the train and test. So what I'm calling train are all the industries that are non-NAICS, non-oil and gas. And we are going to be training in all the data that are not oil and gas, and I'm going to be testing in the oil and gas. So we can run this chunk. I'm doing this in R, and then I'm converting the train and the test to Python. And here I'm going to be running the random forest classifier. And 2 types of metrics, the accuracy score and the balanced accuracy score. And I'm going to explain why. Because the accuracy score is just the accuracy, what is right and what is wrong. If you have a case of imbalanced classes, let's say in a binary case that you have 90% of your data is 0 and 10% of your data is 1. If you create a model that's going to classify everything as 0, the accuracy is going to be 90%. Looks like a good model, but it's not, because it didn't classify any of the ones. So what you want to do is the balanced accuracy score, where you're going to be weighted by the number of times the class appears in the data set. And here we are just loading the random forest classifier. I'm just setting a random state equal 1 for the random forest classifier. And you see that I'm not changing any other of the parameters that you have in here. So that's something that you can play at home. So this is just the standard parameters inside here. And I'm going to be training for the words that we had, and that are going to be the X, and the target is going to be the Y in here. I'm going to be doing the predictions and calculating the accuracies in here. So I'm going to run this one. So it might take a few seconds. It's running a random forest classifier. Remember, we have 207 columns, so with almost 40,000 rows, it can take a while to run. And then in here, in this last part, it's when I'm calling the utils.r, those helper functions in here, to create the confusion matrix and then to plot it with the information that came from the Python. So if I want to use information that came from the Python, I have to use this py $, and the name of the variable that you created there. In this case, it was the predictions. So I'm creating a confusion matrix in here. And then I'm going to be plotting. So we finish to run, and then I can create it in here. So this is the confusion matrix that we have for this random forest classifier. It can look a little small in here, but actually it's going to be a good size for the PDF. And what you're expecting, we have here the true values of the inputs, and these are the predictions. So those are abbreviations of the injuries. The confusion matrix, we are saying how many times the amputation was correctly classified as amputation. So if we just open it here, I guess we can zoom a little bit. No, we can't zoom. But I'll try to see if I can. No. Let's say that a few things that are true, they were there should be amputation, but sometimes it was classified as other stuff, like we see around here. A perfect confusion matrix, we should have ones in the diagonal. So it should be a color only the diagonals. And this classifier didn't do that bad because the accuracy we got here is around 80%, 79.7%, means that it's trying to classify the most common classes. Those are amputations and fractures. But the balanced accuracy is 40%. That's not bad when you have 32 classes, if you think about that. So it's way better than a random guess. So the model is not doing bad, but you can make it better if you change the parameters in here. And after that, you can run and you can have your PDF that you can open in here. And that's going to be your file by the end. So in here, for example, we can zoom in the confusion matrix. So we can see that the amputations are mostly being predicted correctly. We see conclusions are being corrected 100% of the cases. This first fact that's also a head injury was all of them classified as conclusions, so something that you have to look into. And fracture, that are those ones, it's being corrected, and all those other family of fractions, because you can have more than one injury at one time, so it's fracture and something else, fracture and burning and so on, they are being classified in here as fractures. So something that you have to look to go for something that tries to be more diagonal. But that's doing nice. So just to close in here, you can also use the different templates. I'm not going to be providing you, but this is an example of a report that we created in R for the sponsors meeting in Cruise. So we use the Cruise template for LaTeX, and you could use all this information. So you can actually use for the any publication that you want to do, you can create. So those are all the things that we did there. So, and you have all the combinations, you have all the equations, all the reference, and so on. So you can create a very beautiful PDF to deliver to your clients or anything. So I'm just gonna end with a few closing notes. in here. So we are now in the part of the machine learning block. For now, we have 3 already confirmed labs. Probably we're going to include more in the future that are going to be focused on machine learning. I'm going to be teaching like today. I'm going to be teaching how to do a machine learning project. So the first one was the natural language processing and machine learning to classify severe injuries in the oil and gas industry today. The next one, we're going to be talking about faces classification, where we are going to be using, wireline logs to try to classify lithology. And the lab 6 is going to be identifying salt in seismic sessions. And for that, you're going to be using TensorFlow. So probably by the last one is going to be 100% in Python, but we're still discussing that. So that's it that I have for today. I'm going to restart my video. And if you have any questions, please send a message. And that's it. Thank you for joining. So if you have any questions, please let us know.
Thank you, Marcelo. I just was curious when at the beginning you were talking about installing R from Anaconda, and some time ago we have a sort of a discussion about this, and you were mentioning that sometimes with Anaconda, the R installed from Anaconda was giving you some trouble. Is it that you changed your perception of?
No, actually my R is installed separated from the Python installation. So I didn't install R from Anaconda. Usually it gives some problems in the location. Sometimes can't locate where are the R compilers and things like that. So I prefer to do the raw installation of R. First, you have to do the R project installation and then the R Studio. And then inside your R Studio, you can give the location where your Python is installed. If when you installed the Anaconda, you didn't include in the path environment.
So you can install your packages from Anaconda, your R packages from Anaconda, and even if your R is installed separately?
No, the R packages, they always come from the CRAM website.
Okay.
Those are the repositories for the R.
I see. Okay.
But from inside the R Studio, you can open a terminal that could be a PowerShell or a command in DOS, and you can do the PIP in there. And you can enter in your environment and do the installation inside there. You can actually run Python from inside the R Studio.
Right.
So, do you have any more questions?
There is some questions from Paulina and from Marie.
Let's see. Paulina, hi Marcelo, can you show again what are the rows in Tf Idf? Okay, the rows, each one of the row is each one of the accidents, the reports. So let me share my screen again. Let me go back here to the R. And we have here, let's go for this one. We have the data frame Tf Idf in here. So each row that are going to be in here is one of the incidents that you had in the beginning, in the data frame from the beginning. So this is the data frame that we started. So each one of them is one report, means one accident that occurred. So each row is going to be actually continue the same. Each row in the Tf Idf, it's also one accident that happened here, one report by itself. So the difference that the column in here are going to be the words that appeared in the description of the report, the description of the incident, given a weight. So if you go here, the admitted got this weight, 0.35. And by what we have here, that's the only word that got a weight. And for this one, for this row 20, for example, we have more words with different weights. So this was another accident, another report, because it's another row. And we have the arm has a weight in here, the Tf Idf weight. Attempted, there is a weight in here as well. So each row is one different report. So we have another question here from Mahi. Hi Marcelo, why some classes are never predicted in your confusion matrix? Well, that's a very common, that's a very simple model. So we're going to be talking about the confusion matrix. So let's come here. One of the reasons that they are never predicted are, as they are, that could be, oh, wrong button here. For example, like this class, FastFac. What is this class? So let me just go back. In this one, I have what are each one of those abbreviations. So FastFac should be, where is it? Here. Fractures except school fractures and conclusions. So apparently we had words like school that might have appeared in here, but they are not head fractures. So they appear here. So this is a totally wrong classification. This is a fracture, but it's not on the head. And sometimes we have classes like when you see the most common injuries, they start to have a very low number of appearance in here. So we have 32 classes in the total, and here I just showed 10. So you're going to have classes that almost never appeared. So sometimes you don't have the model, enough data to train the model to classify those data that appear very less. So that's why you have to do a work for these imbalanced classes that we didn't do here. Okay, so yeah, another one, it's why I'm removing from the Tf Idf data frame. So it's the same one, the same reason. I'm removing those classes that appeared a very few times, like 1, 2 times only in this one. So I just selected the ones that has a frequency of 100 or higher. And even though, as you can see, it was not enough yet, because the amputations and fractures, they have way more occurrences. So, but sometimes we have a class that appears just once, one type of injury. So you're never going to be able to predict that because you don't have enough data to train a good model for that. So that's why I removed some rows in the Tf Idf data frame. So I think it was the last question. Any more questions? So if you don't have any more questions, I think I'm going to be stopping the recording. And again, I want to thank everybody for joining. And in 2 weeks, we're going to have a new session. We're going to be talking about the faces classification. So, whoops. So I wanted to stop recording. And thank you. So have a nice day.